Nice.
All right. So yeah, I guess let me get my notebook so that I can take the minutes, and then all I had on the agenda today was Lorenz. I don't know if you want to just give an update on your progress with FastAI, since there's been a bunch of stuff, and I don't think we've had a call where we've talked about it
Right.
on the
Yeah, I
record,
was
I
missing
guess.
last time. Yeah, I can do that. I'll just send a link to the documentation. You can find it. So you guys can follow along. Or get an idea. Let me see. Where's the link? No. Go 1 second. Yeah, so that's the repository, and then here's the link to the documentation, and so it's the progress. I think a lot of the interfaces are pretty usable now, and as like sample applications, I've implemented image classification and image segmentation, and there are also all the FastAI data sets from the, I think they had like FastAI had a collaboration with Amazon where they hosted a lot of data sets, and they can now all be accessed to fastai.jl, which makes it really convenient to test stuff out on different data sets and download them. Then in the documentation, there's some tutorials and some explainers. A lot of stuff still has to be written down and documented. So I have a lot of ideas for that. Let me see. So I would encourage anyone to just have a look to the documentation at some point. Oh yeah, there's a learning rate finder already implemented with a plot recipe. You can use the pre-trained model that Kyle has gotten to work, or at least one. I think I have to add the other ones as well. And but there's a proof of concept for that, a notebook that's included in documentation. It's still kind of waiting on the PR from Kyle on Metalhead, because then I can remove the weights from the FastAI repository and just link to that.
Yeah.
And
so
yeah,
the PR should load the weights now. The weight artifacts are uploaded to a repo, and so if you check out the PR, the code in there will be able to download the weights, when necessary, and then load them into the models. The only issue with releasing it is that the models themselves, a bunch of them depend on version 12 of Flux or 0.12 of Flux. And so until Flux makes a new release, there won't be a release of that Metalhead PR.
Yeah, I saw that, but FastAI itself also relies on Flux 0.12 with the output size stuff, which is it's really nice that it works.
Yeah, every time I add a new layer or something, an output size just works as a small victory for me.
So as an explainer, output size is a function in Flux that, given like a model or a layer, and an input shape, basically gives you the output shape of what the model will spit out. So for ConvNet, if you give an image dimensions, you'll know how much downscaling there is and how many channels you get out. And the implementation is nicely based on like Julia multiple dispatch on a type that doesn't have any memory associated with it, and so nothing really happens. It doesn't have to compute anything, but you still get out an array with the right size.
It's very unique. Like I had to kludge together something similar for PyTorch the other day because for whatever reason, none of the frameworks decide that you can easily get the output size of a layer without running the layer and then facing all the downstream consequences of actually running the layer on a dummy input. So output size is very unique in that regard. It's very nice.
No,
I wish it existed outside of Julia.
What do you guys mean by size? Because like you guys say dynamically allocated as like sorry, dynamic typing, right? But then how do you actually store that that data and still have a discernible size about it?
So, well, basically, so the way it works is there's like a dummy number. It's like, so it's a new number type that we defined that if you try to do any kind of operations with that number type, it doesn't do anything. So it effectively requires no compute, and it's a singleton type in Julia, which basically means that there's only one instance of it. So it doesn't necessarily create new instances every time you construct one. And so we create an array of that dummy number. And so whenever, let's say you try to do a matrix multiplication inside your model, it'll go, element by element through the matrices and do this multiplication. But every time it does that multiplication, nothing will actually get computed. And the output will also now be the same dummy type. But as a result of that, you go through all the indices in the output. Now you'll have an output array of the correct size, just with this dummy type as the number.
Yeah, so
That
actually
kinda makes sense.
like all the arithmetic operations are just defined to, so like multiplying, it's called nil, the type. Multiply nil by nil gives, the same singleton type. So it doesn't have to allocate anything. And then the compiler can just, just remove the code because it already knows what the result will be.
So this is best for sparse matrices, right?
Sorry?
If all the variables weren't dummy variables, like if we had to change all the variables at the same time, then it wouldn't be that effective, right? So is it best for sparse matrices?
This is a general purpose. So think of it like tracing. Like if you're familiar with PyTorch's JIT and how that works, where you like run the model and then you trace through and you create a graph from it. This is kind of like that.
But I'll read more.
Okay, but it's kind of like a JIT where like you pass an input size and then you have this type thing, which is almost like a number proxy. It records all the operations done to it, but it doesn't actually run them.
Okay.
And at the end, it'll tell you like what the size of the thing you would have had ended up being.
Yeah.
So
like a trial run.
I mean, in some sense, obviously not mathematical, but with sparse matrices, you try to avoid calculations that you don't need to make because entries are empty, and you can maybe think of it as a sparse matrix with no entries. So we just elide all the computation, and then the only thing that remains is the output size of the array.
Yeah.
And
So
you can also redefine the base.copy method, and so it doesn't actually have to allocate any memory for the output. So I think what actually takes the most time is compiling away all the unused operations.
Okay.
Yeah, I mean, think of it like if you had a vector addition, right? The size of the output of that operation clearly depends on the size of the inputs. So now if you try to, so Lorenz just posted a link to the actual code.
I was gonna ask you about that.
Yeah, but if I had two arrays, if I just had two vectors that were each of size 3 and I tried to add them, and I go to the first and I'm trying to assign the first index of my output and I add the first two indices of my inputs, those are both nil type, so I don't actually do any computation, and the output just gets assigned to the same singleton nil type, so it doesn't
I see.
allocate.
Yeah.
And then you do that for every index, and so now you
Okay.
can extend that all, you know, to more complex operations and stuff. Yeah.
Cool. All right. Yeah, that's something to think about. Thanks.
Yeah, and this is something, you know, that I mean, I don't want to say it's only possible in Julia, right? But in terms of the mainstream or like more popular machine learning languages out there, this is something that you can uniquely do in Julia. And it's made really easy by multiple dispatch.
And
Which,
it's like 40 lines of code if you look at the source file. I think there was like one special case with convolutions that we had to work around, but other than that, it's just worked.
yeah,
So
the
really
only
nice.
yeah. And this works for any model, including, so one of the things in any good machine learning framework, right, is that in addition to the operations like convolution or whatever that the framework provides you, you should also be able to write arbitrary code and execute that as part of your model, and then have that arbitrary code be able to be differentiated, right? So it should recognize functions that aren't part of the framework that someone else has written, that a user has written.
A function as an input to the model in what sense?
Not necessarily as input, but just I could create a model by just stacking up the primitives that are already given to me, like convolution, right? Or a certain layer of my model could just be a function that does what I mean, it doesn't matter what it does, but it's a function that's not part of the primitives, but that I've written myself and defined myself in the code, right? And inserting that into the model as a layer or something should not suddenly break the entire system from working. I should still be able to take the gradient through the entire model, including the user-defined function, and get the correct result. And so all ML frameworks are able to do this. But one of the things that makes Julia really nice is this conversation that we're having about output size, where these utility functions that we've defined also work on those user-defined functions, you know, without any extra effort. And so that's harder to do depending on the utility function in other languages.
Okay.
And in Julia, you could use a much larger subset of the language in the base language. It's not some special domain-specific language that's wrapping C or C++ or something like that. You basically, you just have a freedom to use the language and type system, which is really nice.
Okay. That's a lot of stuff. All right. Thanks, guys. Appreciate the help.
So coming back to FastAI.jl, the way the high-level interface is built is around something called learning methods. I'll just give an example. Image classification, for example, is one learning method, which describes, you know, one way of doing, like, learning to predict a class based on an image. And then you define like an instance of it with like what classes are there to classify it into, what size do the input images have. So the learning method holds all the configuration. And then you can use it really easily to train models on different data sets and swap out the models. And part of the interface for learning methods is a function that takes like a backbone model, like an arbitrary ResNet, and then stacks a classification layer on top. So like a global average, pool, flattening, and dense, which then, you know, outputs the classifications at the classes, which means you can use any backbone architecture for image classification, assuming that the input is like a height times width times color channels image, and the output is poolable. So usually it's going to be like a, I don't know, 8x8 and then a lot of channels output, ignoring the batch dimension. And the problem is, of course, if you have different backbones that you want to use, you don't always know how many channels there will be. And you need that information as input for the classification head, because it has to know how many channels they'll be going in, how many weights you need to make. And then, of course, that's actually where output size is used, because it works on arbitrary models. Even with like user-defined functions, and it basically just uses that to check how many channels do I get, and then it knows how to build a classification head. So it's very useful there to stack together like arbitrary models. Yeah, and most of the examples, there's like the introduction tutorial, basically just gives like a short explainer of how to train an image classification model in a few lines of code, which is kind of the status right now. Image segmentation is actually also almost completely implemented, but I was struggling with the loss function. So how it works, right, is you have an image as input, and then you get out a possibly downscaled version of the image with a channel for every class, and then basically every pixel is like a softmax vector, and then you want to compute the loss. And I haven't figured out to get loss function working that works on GPU because of, I'm not sure. But yeah, other than that, it's also already working. And it's like a very short, succinct implementation that builds on all the other packages. And then both of them, like classification segmentation, also support a lot of different augmentations, like flipping. Of course, they're cropped, and that's using the data augmentation.jl package, which also has documentation.
Lorenz, for the loss function on the GPU, maybe it's worth dropping something in the GPU channel or filing an issue or something.
Yeah. I mean, I just I think I have an idea how to get it to work. I just haven't gotten back to it. I think that it's something with the GPU kernel only being able to reduce over the first dimension. So I think I have to reshape it before permute the dimensions. I mean.
Gotcha.
Yeah. But yeah, if I don't figure it out, I'll open an issue. Yeah, and yeah.
No, you can finish updating.
I was just gonna say the training loop in FastAI is powered by a different package, Flux Training. Has a lot of callbacks, has a callback system. Link to that to get like an idea of all the different features there are, and it's really easy to write new ones. I'm not sure if anyone has done so, but I think it should be pretty straightforward. The implementations are pretty short if you look at the source code. And yeah, then one other thing is the documentation system. Up until 2 days ago, the documentation was being built by publish.jl, which is a Julia package for generating documentation. And I've now switched it to a new package, which doesn't have a name yet. I'm still working on that. That yeah, has some extra features, like it can include the output of Jupyter notebooks, which wasn't previously possible, which is very important because when you're training models on GPU, you don't want to rerun them every time you build the documentation, because that will take like 10 minutes. And of course, if you build the documentation on GitHub, it doesn't have a GPU, so it won't run at all. And you still want to include the outputs and results in the documentation, so other people can see that it actually works. Yeah, and then that package is also kind of built for interactive development, so that it only rebuilds like the file that you change, for example, or if you, it has like code execution if you want to do that, where you can mark cells as executable, and it'll include the output in the documentation. And then you can have it running and it only updates the cells that actually changed. I have some more features also that I'm still putting in, like a lazy server that actually doesn't build anything until you open it in the browser, and then it only updates the files that you actually care about. Because especially like executing code for documentation takes a long time. And if you're using it for live development, then you only want to see the file you're working on. That should speed up things a lot. And then including the source code also in the documentation, when you have like literate comments mixed in as explanations. That's an idea, as well as like the test. So I don't know. I think it'll cover basically everything you need for development work, and show you when anything fails.
So since the syntax of the documentation system you're building right now, at least, is compatible with publish, at some later date, would it be feasible for publish to swap out its entire server for the implementation that's in your package that you're building?
So publish is, the way it's implemented, from what I can tell, is fundamentally based on the common mark parser and the common mark like abstract syntax tree used for Markdown.
Mm-hmm.
So it's very like format specific. And that makes it really hard. The new so the documentation system I'm working on, it has like an abstract representation for XML-like documents, so Markdown and HTML, and then all the semantic transformations happen in that representation as like purely functional rewrites of those kind of trees, and then you only implement for an output format how to write it to a file basically, and then for an input format, how do I convert it to that abstract data structure? And I think that makes it very different from publish.jl.
Okay.
So I think it would be hard to reconcile those two. Publish.jl is also very, it does a lot of mutation, which I try to avoid. So I think the coding style is also very different.
And
yeah.
Sorry, anything else about publish and the documentation system? I'm gonna go on a little bit of it.
I was gonna say that the default implementations right now, they assume the same syntax as publish, and they also use the common mark parser as an input. But it's also possible to. I'm planning on adding support for other input formats. And then if you use that publish.jl compatible format, you can still use the same documentation files to generate, like to use publish.jl for like a LaTeX output, which my package doesn't do currently, because I don't use LaTeX. So I think that's why I wanted to make it compatible, so you don't have to choose either or commit. Yeah.
Cool. Just one comment, just going back to the loss function thing. Even if you successfully work around them, a GPU kernel difference, it may be worth opening an issue anyway, just to see if we can make it more generic. So we don't have to do that in the future.
Okay, thanks, Lawrence. That's a lot of stuff. Yeah, it's been like a couple weeks, I think, since we've formally had an update on everything with FastAI.
Yeah, question.
Go ahead, Ari.
Sorry. So if we want to work on like NLP models in the fast as a like add that to the FastAI.jl ecosystem, what layer of the stack, or what packages should that work interface with? Like where should one get started?
Well, I mean, the basics you always need is you need a model, which I think there's some in like transformers.jl. So you need a model, optimize on loss function you usually have in Flux, and you need a data set. And you also need a way to encode the data, like pairs of inputs and outputs. So you can put them into a model and then compare the model outputs with the targets, right? And that's what the learning task interface is for.
Okay, so learning task interface. Okay, gotcha.
Yeah, learning task interface, exactly.
Okay, that's what I was looking for. Okay.
And then the way, I mean, yeah, have a look at the documentation, but if something's unclear, it's still not very complete, you can of course ask me. I also just linked to the deep learning pipelines documentation, which is mostly up to date. Because it goes further into like why the interface is the way it is.
Okay.
So would an implementation of the interface for a certain task belong in FastAI, or would it belong in DL pipelines? Or is DL pipelines just the interface?
DL pipelines is now just an interface package.
Okay. Yeah, I guess that's a pretty good segue, Ari, because the next thing I was going to go into is we submitted a GSOC proposal for FastAI, to GSOC, and well, I mean, the thing is, Lorenz moves at pretty blinding fast pace, so one of the things we have to think about is what the FastAI project will actually end up looking like. So there's a couple ideas on this front. One of them is kind of related to what Ari is saying. Lorenz, I know you've mostly focused on image data and tasks around that. I don't know if you're planning on moving into language modeling, but if you aren't, I think that would make for a good, GSOC project, is to add a learning task to FastAI around language processing. And then the other thing is the FastAI book. So this is something that we'll have to check with Jeremy to make sure there's no, copyright issues. I don't foresee him necessarily being against us porting the book. However, what I do think he would want to see before then is the docs. Sorry, my screensaver turned on. The docs to be kind of equivalent to what's already there in the Python version of FastAI. So, Summer of Code starts in a couple months here. I guess, Lorenz, do you think that at least on the image task, we will be in a position, let's say by around May, where we can show that the documentation to Jeremy and he'll be able to read through it and make the, direct kind of one-to-ones with what he expects there to be in FastAI and what's there in the package. Because I know previously we shared with him like a bit of your snippets, like as a preview, but there weren't really any docs. And, he had like kind of a list of things like the data bunch, interface and stuff that he was looking for to make sure that that's in there. So will we have that in there, I guess, by May?
Okay. Well, first of all, it's progressing fast because it's FastAI. It's not that called that. Then, yeah, I focus mostly on computer vision, because that's what I'm working on anyway. And I think also having like that slice basically, and going deep and making sure that everything you do with computer vision, FastAI also works in FastAI.jl. I think it's really important, and I mean, it has been for getting the interfaces right. I think they're at a pretty good point now. So I think having an NLP project is a really good idea. And by then there should definitely also be enough documentation for someone doing that, and stable enough interfaces. So as I said, I mean, you need to basically just make data sets available, implement models, implement data processing schemes, and then that's kind of it. I mean, easier said than done, but and the question if the documentation, or if there will be enough I mean, yeah. So you're saying everything should be covered, not to the same breadth, like amount of content, but the same like interfaces considered and stuff that should be doable and also documented, right?
Yeah, exactly. I mean, my basic thought is just that, the FastAI book is his content, and something that is copyrighted. I don't think he would be okay with just a random person publishing a copy of that in another language.
Like a branding thing.
Right, like a branding thing.
I can see
and
that,
so I think for him to say yes, right, he would have to be able to look at the FastAI.jl package. So I think he does want it to be ported just as he wants FastAI to be ported. But yeah, I think as like a branding thing, he'll want to look at the package and through the documentation and say that, yeah, this is a valid implementation of the ideas that are there in the FastAI paper.
Yeah, no, I can see that. I mean, yeah, I also think that it should be documented well, because some of the interfaces are different from the Python FastAI. where I just figured it made more sense that way in Julia.
Yeah, I think probably for us, we'll need like differences between Python FastAI and FastAI.jl kind of section in the docs. That if you're looking for this kind of process, this is how we do it in Julia.
So, sorry, my bad.
Sorry, yeah, go ahead.
Good.
I'm confused about like the relationship between FastAI and Julia and everything about that, because I thought that, well, okay, so I went on FastAI, like fast.ai, and it seemed like a blog, and it looked like also like a tutorial for AI in general, and then so now I see that it's also like a whole library of lots of.
Fast.ai, created by Jeremy Howard, is the Fast.ai website is a blog, but mostly it's a library, which the website is docs.fast.ai, and then there's also several courses that Jeremy Howard taught, I think at USF, on deep learning, and FastAI is kind of the library he built to go along with that course.
Right.
And
and so is Flux our like Julia's implementation of. And
then PyTorch in Python is a deep learning framework.
Yeah.
That allows you to do deep learning, and then FastAI is a library built on top of PyTorch, which makes a lot of things easier, simpler, includes a lot of best practices. And similarly, Flux.jl is a Julia library that allows you to do deep learning in Julia. And then FastAI.jl is built on top of Flux.jl and makes a lot of things easier. Deals with, because there's a lot of stuff besides building models and optimizing models, and that you need to take care of in deep learning projects, like data processing, data sets, evaluation, visualization, and kind of getting all of that into one place where you can do, like, make the common thing, like training an image classification model on a new data set, to make the common things easy. And also to make like more complicated stuff simpler by giving you basically the building blocks. And then based on how complex what you want to do, or how novel what you want to do is, you can use like medium and lower level interfaces to get what you've done. So it's like similar to the FastAI library for Python.
So it's basically FastAI is a organization. It has a philosophy about how to do deep learning, how to teach deep learning, which, like Lorenz said, it's higher level library on top of lower level things, and to facilitate deep learning tasks. And then that library is used for practitioners. It's used to teach deep learning, and this kind of teaching, learning, doing has spawned a whole community around it, reached a lot of people that don't even have any sort of, even barely have any coding or engineering background. So we're trying to get, basically we see Julia as sort of the future of machine learning. Jeremy potentially sees it that way, and he's mentioned Julia and Swift as two kind of successors. And we're working on getting that sort of infrastructure set up. And Lorenz is basically doing most of the work, and Kyle and Brian doing all the organization and everything like that, coding as well. But we're working on kind of sliding into that community as well. So does that make sense?
All right. Yeah, that does. Thanks, guys.
Right. And then officially, I think Jeremy knows about the effort we're doing to build something.
And he retweeted the library, by the way.
Sorry?
Like at some point, he tweeted the FastAI.jl library on his Twitter. So that's some sort of implicit or explicit.
Yeah. So he's approved of it, but I mean, obviously, we're not officially part of the FastAI like group / community. I mean / company.
Yeah, legally speaking, I guess you could say we're not officially part of FastAI. But yeah, I mean, Jeremy knows about the library. He's tweeted about it. We're trying to get it to the point where it's a good enough port. I don't know, maybe he'll consider bringing it more officially under the FastAI organization, or maybe not. That's fine too. That's how open source works.
Yeah, and in any case, I think you know, if he approves, I mean, if he likes the way it's done, he promoted in the FastAI community, and I think that's a great opportunity to build the deep learning community in Julia, because they have a lot of interested people, and I think especially so that's kind of very cool about FastAI. It also addresses a lot of people who are new to programming in general.
So
And I
the
think
main
we as a
motivation is
community-
to reach more
Sorry?
people.
So I mean, there's a few things here. One is, like you said, to reach more people, like spread adoption. The other thing is that, like you've seen, if you look at, for example, the Python side of things, you see there is a proliferation of these higher level frameworks and libraries that are trying to fill in the gap of, well, like how do I go from, say, like raw PyTorch to something end to end, whether that's for research production or something in between. So like there's right now that doesn't really exist in Julia, and FastAI, and to some extent as well, the packages around it. So like Flex Training are designed to fill that gap.
I see.
So regardless of whether or not, you know, it ends up being endorsed by FastAI proper, this is still something we want to have, because it's how a lot of people get into using machine learning who are not perhaps familiar with it or with software development in general. And the FastAI thing was kind of, it helps because there's that, it's a basis to go off of. I mean, as a part-time FastAI skeptic, I mean, I don't, you know, we can debate about what the best high-level design is, but the philosophy is kind of what we're going for here.
I see. Cool.
Yeah, and one thing that Brian mentioned is that there's like a lot of these kind of high-level frameworks, but that can bridge the gap in Python. What we tried to do here when we built fastai.jl is so a lot of these frameworks will build up, you know, this low-level, mid-level tier of interface, and then have some highest level of interface, right? And so what we've tried to do is separate out some of the lower levels into their own packages. So all these packages that Loren shared, data augmentation, flux training, ML data patterns, another one. These target different parts of the lower sections of the API in kind of in a way that's agnostic of whatever the higher level API will end up being.
Okay.
Right, so they don't depend on each other. I think that's a very important part. That doesn't need to be everything in a framework, but yeah, we're building libraries. So you could use data augmentation with any deep learning library in Julia. I mean, even like non-deep learning libraries, of course.
Yeah, and another good point, yeah, I think that Lorenz brought up is that what FastAI has done really well is present deep learning in a way to people who aren't familiar with programming or with machine learning in general. And I think that's a group of people, you know, we don't do a good job at this stage, or with just Flux, we don't explain everything really well in the pure Flux docs of how to get started. And so having something like FastAI and all the downstream packages will allow us to let those users try out Julia for their machine learning, deep learning task. And that's particularly important for our community because the place where Julia shines the most is when people from other domains try to integrate what their problem set with you know, the AD and ML packages that are in Julia. So that's kind of the key feature that Julia has above the competition right now. And this will be a way to attract the users of that that key feature in like a beginner friendly way, and then they can slowly delve into the rest of the system.
Yeah, and speaking of slowly delving the rest of the system, I think Julia has a advantage there as far as teaching and learning, because the whole stack is in Julia, and it kind of has these gracefully like descending levels of abstraction. So, and then you could write your own kind of code somewhere in that hierarchy, and it still works and it's still fast. And it's not just like, you know, you see a lot of tutorials in Python, like write a neural network and like NumPy, but like it's just a toy. You can't really use it. And it's not even the same framework that you're going to be doing your real work in. So you have to learn like 3 different type systems, and you know, it's just not, it doesn't look like the math. Julia, I think, just has a like pedagogical advantage as far as like teaching beginners that want to go like past just the initial like high level layers. So I'm excited about like reaching people and just helping them learn like more about deep learning in that sense. I think Julia
And
could
then
really shine there.
I want to add to that on why it's so important to have something approachable for beginners and also beginners to programming, as per the FastAI philosophy. I think especially in Julia, and I mean this may be anecdotal, but I think it's common in smaller communities, since Julia is a younger language than Python, and has a smaller user base, that I think there are more. There are not that many programming beginners as there are in Python, and it's not that many people's first language. So I think it can be harder, and also because of the small community, I think it can be harder to get started with Julia directly if you're not already familiar with programming. And then having those kind of high-level libraries as FastAI in the domain of deep learning, I think will be very nice for the community. Which then, coming back to what we're actually talking about, the GSOC project on the FastAI book, since we can't
GSOC?
guarantee if Jeremy will approve of it at that point.
What's GSOC?
Maybe, sorry?
What's GSOC? It sounds like a military operation.
No,
Like
it's
JSON?
What do you mean?
it's Google Summer of Code.
Oh,
It's like
the
JSOC.
yeah.
JSOC is Julia Summer of Code. GSOC
Okay.
is Google Summer of Code. It's across lots of libraries
of
and languages.
Okay.
So Google funds a student to work on a project during the summer.
And then they have a mentor from an open source organization who helps them complete their project. And then the result is a contribution to the open source.
Mm-hmm.
Can I?
Right. So we have 2 GSOCs. I mean, there's a bunch of GSOCs that are Flux related, but 2 ones that I guess this team is a little more involved with is the FastAI GSOC to improve that. I guess I'm the mentor for that, and then Brian and I, and then another developer, Julian, are mentors for a distributed training project as well. That's not necessarily FastAI related, but it's kind of one of those lower level pieces that we need to develop in order to get parallel training in FastAI.
All right. So what I was going to suggest, if maybe we don't need to commit on having the project be recreating the FastAI book, but having that we can have that be a possibility, and maybe more in general, create documentation, like learning-oriented documentation. For example, by recreating some of the FastAI tutorials, or if possible, portions of the book, or tutorials from PyTorch or something. And then the specifics maybe don't need to be nailed down now.
Yeah, so I think there's a couple of you here who are interested in the GSOC. And yeah, that's a good point. Like, I guess you will end up submitting a proposal, right, for what it is that you want to do. It doesn't have to exactly match what we wrote when we submitted that project. So it doesn't have to be the FastAI book. One of the ones that already got mentioned today was doing a language processing task, implementing the interface for that, or implementing the task in FastAI. So that could be one project. You could propose that. Or if there's some other domain that you find interesting, that you would like to see there be a built-in learning task for that in FastAI, you could do that. And then in terms of, I know people will want to be submitting PRs to kind of show or demonstrate that they're capable of doing the GSOC. Yeah, some of the stuff that Lorenz just talked about in terms of just adding one-off tutorials that are currently missing from our documentation are good ways to show that you can work with the framework that we've built here and help contribute to it.
Yeah.
So if no one has anything else to add, I think we're at the top of the hour. So
I have a couple things, but I don't know if people have to leave or.
Yeah, I'm pretty dehydrated, so I gotta go and drink some water. But yeah, thanks for the info, guys. It's like a
Thank you for
it's
joining.
like an explosion of stuff I'm trying to take
Yeah.
in. So
yeah,
Thanks for joining.
yeah. So let me just share the link to the Zulip stream. So this is basically where we talk about stuff not on call, offline. So yeah, one call is information explosion, but if you want to just keep following up, that would be a good place to go.
all right, great, thank you. And just I'm curious. So you guys briefly mentioned like the accessibility thing, right? What do you guys think of Michael Nielsen's website book thing? Because I'm going through it right now and it seems pretty accessible. So have you guys like checked that out before? Like,
Sorry, which website are you referring to?
Michael Nielsen, a quantum computing guy.
Oh, like, no, I actually.
Is that it? I posted a link in the chat. Is that it?
Yeah, exactly that. Yeah, it's actually like a pretty good book for just.
Oh, I know the site. I see. Okay, yeah.
Yeah.
No, I think like this is kind of in line with those protocol resources we'd be talking about. Like there's. Go ahead, Ari.
Yeah, I was just gonna say this is kind of different than the FastAI. So the FastAI philosophy is you work from the top down, where you use high level building blocks and you learn how to apply them to like specific tasks.
Mm-hmm.
This is it kind of inverts the normal way where you kind of like learn about the lower level stuff, the matrix, math, derivatives, backpropagation, and use toy examples, and then build up from that. So I think it looks like a cool book. It's just like a different philosophy than the FastAI way of learning it, where you start from like actual like real life like image tasks and stuff like that.
All right, cool.
Yeah, so the Flex docs are kind of structured like this already. Not the reference docs, but more so the tutorials on the site. So obviously there's more than one way to slice this. The only reason FastAI is doing it the way it is because FastAI upstream does it that way. And the whole framework is molded around that idea of progressively revealing more and more of the internals as your problem gets more and more difficult. But there's no saying that this doesn't work. I think, like, for example, if you've seen, is it Terrence Parr of Antler fame, who made also a similar book about ML, which is like
Nope.
this as
I've
well,
not seen that.
but similar to what you linked. So yeah, it's just a matter of philosophy around like what you want to get out of the book. And in FastAI's case, the idea is to work with models rather than to learn about how they work.
I see.
I want to plug here also a different framework to think about documentation that I found useful to consider. It splits the documentation in 4 different parts. Tutorials, which are learning oriented, how-to guides, which show you how to do something very quickly, explanation, which is like more background, and then reference, which is like all the details.
That quote's pretty funny. The grand unified theory of documentation.
But I mean, that's one slice, right? It doesn't say anything about bottom up or top down. But I agree that the linked book, I've read it, but it's very like bottom up. I mean, it starts with like single neurons. And then if you look at the FastAI book, and I think the first code example you see is like 5 lines that train a state-of-the-art image classification model.
Cool.
Which like,
yeah, I think if you if you come with a problem background, the top-down method works really well because you may not have the mathematical or coding background. But if you have, let's say, the mathematical background and you just don't know about the specific application of machine learning, a bottom-up approach is can be quite effective. So I mean, I guess I can't, like Brian mentioned, the only thing I can think of that's bottom up is the Flux docs, but it's mostly focused on a bottom up presentation of the Flux framework rather than a bottom up presentation of the idea of neural networks. But yeah, I mean, I guess let me double check and then I'll update the Zulip stream. This is my first time mentoring a GSOC, so I'm not sure exactly on the details, but at least from my point of view, if someone were to put together a repo that complements the docs in FastAI, but takes a bottom-up approach to teaching something using Flux and all of the other packages that we have, I mean that's still good to me. It demonstrates that you can use the packages and that you understand what's going on, and you understand how to write a tutorial and documentation, which is, I think.
And if you're inclined to do that, it'll help teach you and reinforce deep learning for you as well. So if that's something you want to do, and given your background, I think you're really well positioned to do that.
Thanks. Yeah, that sounds like a good idea. I actually wasn't even thinking of that, but yeah, that's really a good suggestion. I will definitely check that out.
So, I mean, yeah, one thing you could do is look into Lorenz's documentation package or into Publish. Or since there isn't necessarily source, there isn't like a package that goes along with this, you could even just set up like a website. Let me post it in the chat. It's called franklin.jl. That makes it really easy to take in Markdown or Julia source and turn it into a website. So those are all tools you can use. And yeah, I mean, if someone were to do a bottom up kind of style tutorial, I think that would help the community a lot as well. We don't have to have one or the other.
I think there's some bottom up sections in the FastAI book as well, if I recall correctly. Does anyone remember if that's the case? Okay, I don't know. And
yeah, I'm not sure.
There was
even if there isn't, it's a pretty good exercise just to like teach it to yourself again.
Yeah, I know, and it'll be hugely valuable because even if people start out with top down, it's a good idea to learn the nuts and bolts, the bottom up stuff as well.
Hey guys, if there's nothing more directly to me, then I gotta run.
Okay, thanks for joining.
I do have one thing, and just I just want to get your thoughts on this. So this guy from Facebook, one of the PyTorch devs I've been having a conversation with on Slack, and Brian's in that thread. He asked me, I kind of threw out as kind of like a half tongue-in-cheek comment about Facebook doing a Julia for PyTorch or Julia for Torch thing as a analogous to Google's Swift for TensorFlow. It was kind of tongue in cheek, but he kind of bit a little bit, and then I was selling Julia pretty hard, maybe a little bit too hard. But he just sent me he just posted a comment. What can I say? I got excited, but he just posted a comment and said, out of curiosity, do you think people would be interested in something that lowered from PyTorch code to Julia? So I was wondering if A, what you guys thought about that, and B, if you had any specific ideas for how that would be helpful. So, and then I responded, so I asked him, I was like, do you mean as an execution backend or more for using PyTorch models easily in Flux or Julia? And he said both, I suppose. So any thoughts on that? I mean, obviously everyone who does machine learning in Julia would be happy to be able to use PyTorch code. But maybe something like you have people in PyTorch write data classes and they could use like custom like types, like translated Julia types, or write GPU kernels in Julia and then have it integrated. I don't know. Do you have anything I could tell him that would?
So with the
Think about
preface,
it, maybe write something later, but I gotta run now.
yeah.
Okay,
Thanks.
sorry.
Okay,
Bye.
bye. Thanks.
Very good. Bye.
Bye. So I'll
Um,
just preface this.
Just
Oh,
first
go ahead,
off,
Kyle.
do you have a link to the thread?
Okay, I gotta go too. I'm
Alright.
starving. So yeah, see you
Yeah,
guys.
thank you.
Thanks for joining.
No problem.
Excuse me. I have a suggestion for this. You said that recreating Fastbook could create copyright issues, right? What if we try to recreate the tutorials from Jeremy's previous year courses, like 2019 notebooks? Those notebooks aren't that, you know, that hectic to recreate, but that covers the crux of what the breadth of the FastAI library. That would cover the breadth of the FastAI library, I guess.
Yeah, I mean, there's a lot of tutorials just in the FastAI docs that are not copyrighted, and we are porting those. Yeah, I mean, any random tutorials that are not copyrighted, of course we can port. But yeah, I mean, yeah, that would be a good contribution if that's what you're asking.
So I'm interested in writing a tutorial. So what should I do?
So let me grab a link. So here's a link to the repo. I mean, I guess I would start off. I mean, if you already have an idea of the tutorial, I would just start off by filing an issue on the repo with a link to the tutorial that you're trying to recreate, and what the goal of the tutorial is going to be. And then someone can reply back with some guidance on how you would actually go about writing that into the official docs and developing the tutorial. And then you can take that and submit basically a PR to the repo that adds that to the docs. And once you do that, we'll basically review what you submit, give you feedback, and eventually merge it once it's ready.
So once after creating the issue, the docs document, I mean, the tutorial should go to the docs folder, right?
Yeah,
In the
it'll
repository.
go. Yeah, I guess I can just. Oh, I guess this is actually
Oh, okay. There is a
Lorenz's.
tutorial folder. I saw it.
Right. So you can add basically a markdown file to there that'll have the tutorial. You can look at the other markdown files as reference. And then there's basically this file, the table of contents, that actually builds, tells you what goes into the docs. And so you'll basically, you know, add a bullet for your tutorial in there, linking to the file that you add, and then that would basically be your PR. And then of course
So
we'd review that content.
and also so we can't use IPython i.ipynb file for tutorial.
No,
Only it
you
should be in
can.
MD.
Yeah,
Oh,
so that's a Jupyter notebook, that extension, and the JU in Jupyter stands for Julia.
wow.
So yeah, you can submit it as well. You'll see that there are a couple of notebook files in the docs folder. So you can look at those for reference. So the only thing to note with the notebooks is that they don't run when we build the documentation. So, right, when you run a notebook, the output from each cell gets saved as part of the file. And so that's the output that'll show up in the doc. So that's the only like thing to remember when you write a tutorial using a notebook, is that you run everything and make sure the output looks like you want it to before committing it.
Oh, okay. So okay, thank you so much, Kyle. I would like to write a tutorial for it.
Yeah, that would be great. We'd love that.
Yeah. So okay. By the way, this is midnight here. I'm gonna leave the meet.
Sorry, I didn't catch that last part.
No, it's getting really late here, so I'm gonna leave.
Yeah, no problem. The meeting technically was supposed to end
Oh,
anyways, but thanks for joining.
Thanks for joining. Nice to meet you.
yeah. You people seems like very cool kind of. This is my first meeting with the real open source community, and you people are really cool. I love it. I'll try to attend every community call every 2 weeks.
Great. Yeah, we'd love that. So glad you're enjoying yourself, and yeah, hope to see you. You can join the dev call is on Thursday of next week. Otherwise, we'll see you in 2 weeks again on Tuesday.
Yeah, sure. Okay then. Bye.
All right, good night.
Bye. Okay, Brian, sorry, I think
Sorry,
you
if
got
we're doing,
interrupted.
I guess we could stop the recording if we just want to do freeform talk about this stuff.
Oh,
I
yeah.
don't know if it fits in the Q&A.